Okay, let's get started. Welcome to week 2. Everyone's still here. Everyone knows their own name. We're all good. Okay. So I see that most of you have managed to get deliverable 1 submitted. So I'm assuming most of you have managed to deal with all of your various installation woes. I know there are still a few people that are struggling with installation issues. Please make sure to see myself or the TA this week to get things worked out so that you can get deliverable 1 all tied up and you can get started on deliverable 2, which is due next Monday at 11:59 p.m. So I walked through deliverable 2 with you last week. Basic issue in deliverable 2 is you're translating from 2D to 3D, right? In deliverable 1, you have this point where you're throwing away all the information from the hand except 2 of the 3 coordinates from the tip of the index finger. So you're moving something in 2-dimensional space. In deliverable 2, we're now going to be drawing the hand as a wireframe in 3D space, which means you're going to be making use of the 3D drawing utilities in Matplotlib. So hopefully there won't be too many issues with that. Any questions about deliverable 2? No, we're all good? Okay, so let's carry on. We are a little bit behind, but that's all right. We're going to finish up lecture 2 today, the basics of interaction, and move on to PACT analysis, which is the who, what, where, and when of HCI. So P is for people. Who is going to be using your software? Activity is the what are they going to be doing? And C is for context. When and where are they going to be doing it? Once you think a little bit about the P and the A and the C, then you can start to think about the T, which is the technology. So we're trying to scope out sort of who, what, where, and when to start in then on the design process of actually thinking about how to support all the different Ps who might be carrying out different versions of the A in lots of different Cs or contexts. So we're going to transition today from sort of this introduction and overview into design issues specific to HCI. So let's jump back to lecture 2, and just to refresh our memory, what we kind of ended with last time was this statement at the top of slide 15 here, which is HCI has 2 feet in 2 different camps. We're going to draw a lot of the theory and the conceptual ideas in this class from psychology. What do people expect when they interact with a thing or a person? And for the technical side, we're going to rely on software engineering and computer science to develop the technology to support those expectations in an interaction. We ended last time by sort of unpacking the I of HCI. So when someone interacts with your system, there are lots of different kinds of interactions that are going on at different time scales. Some of the interactions are very obvious, and some of them are less obvious. And the black art of HCI is being able to identify those less obvious interactions and being sure to support them in a good way, right? So physical interaction is kind of obvious. Someone's looking at the screen, someone's waving their hand over your leap motion device. Perceptual interaction is that feedback loop between I do something and I see or hear the software react. And then conceptual interaction. I'm expecting that if I do this, a tenth of a second later, or maybe a few seconds later, I'm going to get this kind of thing back. We ended last time with an example of a Wii Remote and thinking about trying to create a bow and arrow video game for the Wii Remote that would help support the physical, perceptual, and conceptual interactions, right? So I release the arrow from my Wii Remote, and I hear it hit I hear the target through the speakers on my TV. That's pretty straightforward. The perceptual interactions is I then notice that there's a delay between the sound of the arrow leaving and the arrow hitting. So that helps to support the illusion that I'm actually shooting an arrow. Finally, I build up then a conceptual interaction. I expect that if I move back and release the arrow, the delay between those 2 sounds is going to be longer. If that conceptual interaction is not, or expectation is not supported, I'm going to be confused or frustrated or go use somebody else's video game. Okay. All right, so now we're going to switch back sort of to the human part of HCI. I mentioned this several times already. we try and think about who is going to be using the software, and we try and focus on our demographic first before we go off and try and design the technology. It's very easy to say we're going to put people first, but what exactly do we mean by that? So we're going to sort of unpack that in this course. So when I mention putting people first, we mean lots of different things. So first of all, we want to try and think about what people want to do with the technology rather than what the technology can do. You've probably all interacted with software or apps where clearly the designers pushed the envelope of what could be done technically, and it was completely unusable, right? So you get the Leap Motion device, and you immediately think of all the things you can do with it, which is great, but we also want to focus on what people want to do and make sure that we focus the functionality to support that need. If you think about the history of killer apps, most of the most popular software packages created ways for people to interact in new ways. A lot of the software that's out there allows people to interact in new ways, specifically to synergize collaborative effort, right? Making it easier for people to work together. A lot of good HCI out there also, again, assumes that the human in the loop is not a passive observer, but wants to participate in the design process and fundamentally change the software or the technology. So what sorts of technologies allow people to alter the software itself? And then finally, we're going to spend quite a bit of time talking about designing for diversity, right? People differ in physical, perceptual, and conceptual ways. What are some examples of software where these principles have been embodied well, and what are some examples of software where these principles have not been embodied so well? Let's start with the first one. You think of examples of technology where clearly they were thinking about how someone was going to use it? Or the opposite, they didn't think very well about how someone was going to use it.
GPS system for a car.
GPS system for a car? How so?
I mean, it's able to be typically mounted on the car, and it updates live while you drive around and gives specific instructions. I mean, admittedly, like the early versions of that technology were kind of annoying. They would tell you like kind of over and over like wrong information sometimes.
Okay. Exactly. Most mapping GPS software now has vetted sort of how people are going to use it, and again have thought about the context, right? Something is probably going to be mounted on the dashboard. You may or may not want to be drawing the user's eyes to the smartphone, right? Most GPS software comes with the voice, right, for obvious reasons. You need to think carefully about what the person needs to do, which is keep their eyes on the road most of the time. Okay, that's a good example. What about a poor example?
The Nintendo Wii, well, it is a good example for some aspects.
Okay.
When they originally released it, it didn't come with the wrist strap.
Okay.
And they didn't think about people would that they would just let go of it and it would send it flying through their TV.
Okay, excellent, great example, right? Ergonomics, we mentioned that the physical fit of technology matters. What about the second one, the history of killer apps? What are the killer apps that allowed people to interact in new ways?
I think Snapchat was intentionally unintuitive.
Okay. Was it intentionally unintuitive?
Yeah, I think that
Why intentionally?
They kind of designed an interface that was not obvious and had no explanation.
Okay.
And kind of developed a exclusive sort of following amongst like a demographic that was much more likely to use it.
Okay.
So it does keep out a certain other demographic.
Okay, right. So it advertises to a particular demographic because it's the interface is not so obvious. Other examples?
UVM website.
The UVM website. Okay. How so?
Well,
Where to start?
Yeah, it definitely is a good example of what technology can do, but not what would be the best access for most of the people that are using it.
Can you give a specific example? Why not?
There's just like a lot of information on each page. It's your eye is drawn to a million different things. The font. There's no contrast between any object.
Okay. I think I would agree with that, right? There's very little thought on most pages about who's going to be visiting that page and what they're trying to get out of it. Let's focus on point number 2 here. So creating new kinds of social interactions that didn't exist before that software or that app existed. Pokemon Go, that's a great one. Okay. Very recent example. Uber or Lyft, yeah, exactly. Right? It's sort of new social interactions around Uber. That's a great example. Voice control for your TV. Okay, but we're focusing on new kinds of social interactions that are created because of the technology.
This isn't exactly new, but Skype was pretty revolutionary.
Absolutely, right? Finally, someone had figured out how to do the video phone, right? It's not perfect, but pretty good, right?
Venmo?
What's that?
Would Venmo be one?
I don't know what Venmo is.
It's
Enlighten us.
Venmo. It's a way for people to pay each other through their phones through an app.
There you go, right? Exactly. So financial tech is probably going to be the next round of killer apps. If you go further into the past, email, right? When email came out, this was amazing, right? Email, all the social networks, tweeting and so on, the recent examples that you've given. Most of these apps created new kinds of social interactions that were difficult or impossible before, right? All of the more recent apps and software, socialized computers. In the old days, you had your own machine and you kind of hacked at it and you may communicate with people outside of a computer network. Now it's more and more social. Okay, so let's again focus on supporting things that people want to do, which is socialize and interact. Let's move on to point 3, which is a particular kind of social interaction, collaboration. You want to work on a project together. What kinds of software exists out there to support those kinds of interactions?
Google Docs.
Google Docs, why has Google Docs become so popular?
Multiple people can access it and share that with people you're working with, so you can all see what they're doing on the same time.
So you can see what everyone's doing at the same time, right? Real-time editing. People had tried to do this before, but Google Docs somehow got this right. So there's that specific kind of social interaction, which is you can all be writing or modifying a document at the same time and see the results of those interactions, right? That's a pretty powerful innovation.
GitHub?
Yep. Sorry, GitHub? Okay, so what is it about GitHub that helps collaboration?
Source control, so if someone screws up the code, you can always just go back to what was actually working.
Okay, and again, there's been version control software before GitHub. What was the particular innovation that allowed GitHub to win, so to speak, at least for now? Yeah?
You can pull the newest stuff from there and work on it yourself.
You can pull the newest stuff from there, right? You can push an update. You can fork a repo. Think about the language surrounding GitHub, right? Those verbs, whether intentionally or unintentionally, make things very intuitive, right? If you're a person coming to version control software for the first time, it can be pretty unintuitive, right? But if you think about it, there's something out there and you pull it, you modify it, and then you push it. If you want to leave something and fork and create a parallel track, it's all very intuitive language, right? Again, that's thinking about how people are going to interact with it and who might use it, right? So today everybody uses computers, everybody has documents, everybody forgets which version is which. There's more and more people who are not necessarily computer scientists who are using version control software. That intuitive language really helps, right? Doesn't have too much to do with the underlying technical guts of GitHub itself. It's sort of the whole package or the culture of GitHub. It's a great example. Okay, let's carry on. Point number 4. So involving people in the design process. So software that makes it easy to be modifiable.
I mean, this might not be what you're looking for, but
Yep.
like, there's tons of video games that are released that are in like betas or alphas even,
Yep.
Specifically so that the developer can like watch what's happening and like see how people are interacting with the game, and then fix problems or like so. It's not so much that people are directly involved in the design process that they're assisting the developers with the design process.
Absolutely, right? So alpha and beta testing more important than ever before, and a lot of new video games or new software allows some sort of actual modification by the alpha or beta users, right? We're going to talk about that when we get to the design process. If you're designing a video game or something that has a subjective aspect, you need to see how people react to it. Other examples? Yep.
I'm not sure if this is what you're looking for, but like social media platforms that allow people to like customize their page and they can design their own presence on the site, kind of.
Absolutely, right? So imagine whatever website you tend to use, it would be hard to think of a website that isn't customizable somehow, right? That definitely was not true just a handful of years ago. Most users expect whatever app or page or software they're using, that it's customizable to the way in which they want to use it. Yep.
Yeah, I guess similar to that, on an iPhone, how you can move around apps and kind of create folders so it works most efficiently for the individual.
Exactly, right? Again, it seems obvious. If you're the latest smartphone, if it didn't allow that, you'd be on to the next smartphone, right?
Would like usability tests be one of them, like just how before they even release things, they get people to actually try it and see how it works for them?
Yes, so a usability test might count here, but we're thinking about specifically cases where the tester in this case can go in and actually make a modification or customize something, right? Not just passively drawing data from your alpha or beta testers. Things where the human can reach in and make modifications to the system itself.
Are you just talking about like QA testers or?
It could be QA testers, but again, something where they can actually make a modification to the system itself. Operating systems, right? You can reach the whole Linux culture, right? The assumption in that culture is you can change the platform itself as deep as you want to go, right? That's a great example. The Linux community. Wikis, again, now kind of obvious, but when they first came out, they were pretty revolutionary, right? A wiki was a web page that you didn't have to really write any code to change. This was revolutionary. Okay, designs for diversity, right? We've already talked about this quite a bit with the Leap Motion device. Not all of you are righties. We all have different sized hands. We have different skin tone. You need to, the Leap Motion designers and you are going to have to think carefully about the diversity, at least in this classroom, when you create your system. What are other examples of interactive technologies out there where you can tell that the designers thought carefully about diversity, or that they failed to do so?
Being able to set the language.
Yep, absolutely.
Text size in your iPhone.
Text size in general, right? There's usually a shortcut, or it's very, very easy to change text size. Why? What aspect of diversity is that responding to?
Just disabilities with vision.
Everyone has different vision, right? Or just prefers large or small font, right? Your preferences. Yep.
Even how in Africa they had to change the icon for Wi-Fi because it meant something completely different to them.
Hold on to that one. I'm going to come to that example in about 20 minutes. So don't give that one away. Okay, hold on to that one. Yes? Different skin-colored emojis. That's a great example, right? All these aspects of political incorrectness, right? You need to think carefully about who is using the software.
Just like the relative ease of switching between different languages and software and operating systems.
Exactly, right? You need to make it easy, because if you turn on a computer and it's in a language you don't speak, how do you find the language switching capability, right? All of these things which seem obvious once you think about them, but hopefully what you get some experience with and some intuition about in this class is trying to think about those things before final deployment. Right?
When you design a website, taking into consideration disabilities, like managing like headings for tabbing for blind people or text on images, things like that.
Absolutely. So, right, we're going to talk quite a bit about diversity. Just for fun, go and Google, software for the blind and for the deaf. There's some fantastic innovations about there about how you actually design for someone that can't see what you're projecting on the screen. Okay, again, I've got my own examples here, but you can fill them in. A big one that we will come back to over and over again is the KISS principle, keep it simple, stupid, right? Google got this right at the beginning, and they've managed to minimize the amount of visual clutter on their landing page. Yes, PageRank was also important, but it did help that there was just a bar. You typed something in, and you said search for that, right? Okay, again, connecting people to people, you go through the history of software, most of the killer apps, that's what they did. They created a new way for people to interact, or at least interact in an easier manner. Okay, we mentioned Wikipedia, wikis, and so on. We're going to come back to CSCW, it's a terrible acronym, Computer Supported Collaborative Work, which is a subfield in HCI that focuses specifically on that. How do you bring together a large number of diverse people in different places that are trying to work on a common project, right? There's a lot of interesting ideas there. HTML made it a little bit easier to create web pages. XML made it easier still, and then Wikipedia made it even easier. Wiki made it even easier, and now you've got Fourspace and all those other web design widgets and so on, right? Easier and easier to create online content. Usually changing font size, it's very, very intuitive and very obvious. Okay, so that does it for lecture 2. Let's just hop back to the schedule for a moment. We're going to switch now to sort of taking all these random observations and try and systematize this a little bit. So before we go about trying to design an ASL game for Leap Motion, we want to think about who's going to use it, how are they going to use it, and when and where are they going to use it, the P, the A, and the C. Then we can think about the T, the technology. Okay, so how do we begin thinking about creating interactive technology? We need to identify these 3 aspects. So we're not going to talk too much about design today. We'll get to that when we get to lecture 4. We want to try and resist jumping into design and thinking about all the functionality we can add on top of Leap Motion. We want to hold off on thinking about the T until we've clearly thought about P and A and C. So again, the P is the who's using it. Activities, what are they doing? And the context is when and where are they doing it? Okay, so let's think about this a little bit by taking 3 examples. Here are three different hypothetical technologies. In each of these 3 examples, I've identified a specific demographic. In the first case, teenagers. In the other case, people that are flying drones. And in the third case, a worker who is working right next to an autonomous robot. So we have the P in each case. We have the activity in each case. So the teenagers are texting, the people are flying their drones, and the person is working alongside the robot. The technology is kind of mentioned here. So we've got a robot, we've got drones, and obviously if we're talking about texting, there's a smartphone implied in there. So imagine you were tasked with writing software for any of these 3 P's and A's. So take a moment to think about that. Now, think about how you're thinking about the T, about the technology changes, when I add some context. When and where are they going to be doing this, right? Assuming you know how to write an app, it's pretty trivial to write a texting app, but the game changes considerably when your specifications for the software specify that people should be automatically barred from texting while driving. So there are regulations in place now to guard against that, but can there be something in the software itself that helps enforce that regulation? What happens if people are flying drones at a large-scale protest march? And in the case of the person working alongside the robot, what if the person is deaf? All right, let's start with example 1. How did your thinking about this texting app change when I added this particular piece of context?
Well, mine changed to be hands-free voice control then.
Okay, hands-free voice control, that's one option. What if somebody says, I don't want a voice control, I'm going to text anyways while I'm driving? We could ask them to switch over. Can we automate this in any way?
I mean, you could use like the phone's GPS system to lock the keyboard while it's moving.
Okay, so we could use GPS or the accelerometer in the phone. We could try and use the sensors in the phone to infer that the person is in motion. think more carefully about the context. That's a good start. There's a problem with that particular approach, though.
Well, the problem with that would be if you're a passenger.
There we go, right? So now we're diving deeper into the context. We want to try and block. Tactile texting in the driver, but not in the occupants of the car, or someone who's texting on public transport. Autonomous cars, okay, maybe we'll get there someday, and then this issue will be a non-issue until we get there.
You could like collect data on how fast they text, and then if it goes to a certain point, because when you're driving, you're not texting as fast,
Oh.
you could do that.
Okay, we could try and add on some machine learning to try and infer from the activity itself, try and guess that they're driving, which might work, but obviously it's not. It's going to be error prone.
You could try to have it where they put like both thumbs on the phone to lock, say unlock and passenger, both hands on the phone.
Okay.
That would then encourage someone to just drive with their knees.
There we go, right? So unintended consequences, right? If you want to unlock the voice version, you have to press with both thumbs. Aha, okay, that's easy enough, right? So again, thinking about the person in the loop here. Other ideas?
I'm just going to say, I know Samsung has some facial tracking, so maybe see if they're actually looking at the phone or if they're kind of doing this sort of thing.
Okay, so we could bring a bunch of these ideas together, right? We actually will talk about face recognition. So maybe we turn on the camera, something about how they're texting. We might be able to bring together a lot of sensors to bolster our prediction or improve our prediction that someone is actually trying to text while driving, right? Not perfect.
Start making cars that have like the front seat, like an area in the front seat that will communicate with the phone.
Sure.
Tells it that you're in the front seat.
Why not, right? So we could try and put something on the phone, but again, thinking carefully about HCI in the context, we know we've got a phone in the equation, but there is other TE, there's a constellation of technologies surrounding this particular activity in this particular context. So maybe we work with car manufacturers on a localized dampening zone, right? Or they have to plug in the phone, or maybe there's some combination of a modification to the car and the phone that would help with this issue.
Well, that technology already kind of exists with seatbelts. So
With seatbelts.
I know, my girlfriend's car, if I sit in the passenger seat, it senses I'm there and it will ding incessantly until I put my seatbelt.
Yes, exactly, right? So there's lots of different solutions we could bring to
You
bear
could
on
use
this.
that technology, link up to the car and find out the person sitting. It's already there. It's just a matter of getting the information, I guess.
Okay. Let's move on to the second example. So we want to write some software for drones to take photographs, or people are flying drones together, so maybe some software to communicate between the drones. How does your thinking about that kind of software for the drones change the moment you think about where these drones may be used?
Sensors in them, so if there's a lot of drones flying around, that it can sense if there's a drone nearby, so there's no collisions, and then it follows and hits people.
Exactly, right? So maybe we have a lot of drones. We definitely know now that there are a lot of people in close quarters. What else about this particular context changes your thinking about writing software for drones? Yes, they shouldn't collide with one another, but that's probably true in general. Okay, so how does that change your thinking about writing software for this technology? What's that? Feel bad, okay. Maybe go back and figure out, is this something we need to explicitly address in the software?
You have to make sure that it'll work when there's a lot of people around all using the same resources that you're probably going to be using.
Which is?
Probably cell networks.
Exactly, right? So you've got the people that are flying the drones, and now you have stakeholders, so people that aren't using the technology themselves, but they also have T associated with them, which may be indirectly influencing the functioning of your own, right? So again, we need to think about that. Is the drone going to work? Is the obstacle avoidance software going to work when there is suddenly a lot of cell phone usage or Wi-Fi usage or what have you, right? Maybe we test 10 people flying 10 drones together at close quarters. The obstacle avoidance software works perfectly, right? We did our alpha testing, our beta testing, release it out there. It gets used in drones at a large-scale protest march, and all the drones fall out of the sky, right? There's something about the change in context that suddenly changes things a little bit. I'll tell you a short anecdote. A few years ago, I was at a big conference in the EU. It was about robotics. They had about 1,000 attendees. And at the opening ceremony, there were some EU officials that were going to come out onto the stage, and a robot was going to drive out with some big scissors and cut the ribbon to open the conference. And the twist on this was that the robot was controlled by an EEG band being worn by a grad student who was sitting just behind the curtains. So it was being controlled by this grad student's thoughts. I got there early, was sitting in the front row, and I could see the grad student behind the curtain practicing, and he drove the robot out onto the stage and did this 10 times in a row, no problem. 1,000 people filed in, the EU officials got on the stage, the music started up, the lights came up, and the robot failed miserably. Someone had to come out and cut the ribbon. Why did the robot fail?
He's nervous.
Because he was nervous, of course, right? So EEG picks up oscillations in brain activity near the periphery of the skull. Those oscillations, even if you're not a neuroscientist, it's pretty obvious that they change considerably if you're nervous, right? No one thought carefully about the context of that activity and who would be using the technology, right? There's hundreds of examples like that out there, right? We need to think carefully about who is going to be using the technology and where and when are they going to be using it. Okay, so we're trying to scope out who's using it, what are they using, and when and where are they using it. A couple slides back, I sketched out this little cartoon of a person who does something. The software senses what they did, projects something back to them, and the human user receives a sensory repercussion to their action, right? This is what John Dewey talked about over 100 years ago. So we have this sort of feedback loop that's going on with someone who's interacting with their Leap Motion device. In HCI, we also focus on this much longer feedback loop, which is the moment somebody, once the moment somebody provides a novel interactive technology like Twitter or Uber or drones, suddenly there are a whole bunch of other new activities and contexts that become possible that didn't exist before. So we identify people and the activities they're going to be carrying out in context. We take all of that and we boil that down to a set of requirements. So we want to actually write out what exactly the software should and shouldn't do. We create the technology based on those requirements. We deploy the technology out there. It either does or doesn't get adopted. As it becomes adopted by more and more people, people realize there are ways to adapt this technology to create new sorts of opportunities and new ecological niches for new apps and new software and new hardware and so on. So a lot of people have become very successful in the computing industry and HCI in particular have not only thought about what happens when I deploy Twitter and everybody starts using it, but how are things going to change and what are the opportunities for new software on top of large scales of people that are using social media pretty much all the time. Okay, so I want you to try and keep this in the back of your mind as well. We have this very fast feedback loop between people and technology as they physically interact with it, and then this longer feedback loop, which is more of a social or cultural feedback loop. What are new opportunities that are created when large numbers of people adopt new kinds of technology? Okay. We're not going to talk too much about requirements in this class. That's something that's tackled more in the software engineering class, but there's an art to writing good requirements, which is to take what you've observed about people and the activity in the context and boil that down to a set of requirements. So carrying on with the example, two of the examples we just talked about, what might be some very specific requirements you would write for the co-robot? So a co-robot is a robot that cooperates with a person and is also co-located with the person. They're standing right next to them. What would be some requirements for our driving-proof texting app? And let's focus on trying to think up some requirements that address context, right? So obviously we could say a texting app should stop texting when someone's driving, and a co-robot should be safe around the person that's standing next to it. But can we be more specific? Can you think of some requirements that take into account that context that we just talked about? Let's go back to the example of the co-robot for a moment. Right? There's lots of different people that may have to work very physically close to a robot. What requirements would you write for the software engineers that are going to write software for this co-robot that makes sure that this robot is going to be safe when lots of different kinds of people work right next to it?
Decent proprioception, I guess.
Decent proprioception in the robot?
Yeah.
Why?
Where it is in location or relative to other objects.
Okay.
So it doesn't just like bumble into a human.
Absolutely, right? So if the robot is trying to do its thing and it feels, which is proprioception, it feels that it's touched something, it should know that, right? And then we probably want to write some requirements that say don't just keep doing whatever you're doing. Actually, the Baxter robot that you see in this picture here, created by Rethink Robotics, this was the big innovation of the Baxter robot, which is actually very challenging in robotics, is sensing whether you're actually grabbing a physical object, in which case you should carry on doing what you're doing, which is to pick it up or drill a hole in it, but to be able to distinguish between a physical object and a human being. If you bump into something, what is it about your proprioceptive information that helps you distinguish between, is this a thing or a person? Obviously important if you're developing a co-robot. What would be some other requirements, either for the co-robot or for our texting app here, that take into account the context in which it's going to be used?
The ability to interact with different types of people, maybe a visual screen for someone who's deaf or auditory for someone who's blind.
Okay, so if you look carefully at Baxter here, Baxter does have a screen. Is that sufficient if the person working next to Baxter was deaf? Physical context, right? What is it that they're doing in this picture? And why is the screen not sufficient for a deaf participant in this case?
Not facing.
It's not facing them, right? Again, okay, now it seems obvious, right? So maybe a requirement would be that a co-robot always has a visual output, in this case a screen, and that screen should always be oriented towards the human user, right? That immediately raises hundreds of other requirements about how you're going to achieve that technically, right? The robot is going to have to sort of sense where the person is and make sure that it's always projecting something visually towards that person, right? So now that we've thought very carefully about the P and the A and the C, it starts to influence how we think about the T, right? We can't have a fixed screen. It's got to be a screen that rotates. There has to be some sort of sensors that detect where the person is and uses that to orient the screen towards the person.
I was thinking, wouldn't it just simplify it if you wore like a badge that the robot could sense so that it would understand, like, don't pick up this object?
Absolutely, right? So maybe we want to introduce some additional technology, some badging or some wearable technology that the human participant has to wear in order to do this.
And like with those though, like, because they don't allow jewelry or like things that hang when you're working close to machinery, because it could get caught and then.
Okay. Great. So now we were thinking like HCI designers, right? We could imagine a badging or wearable system, but now we need to think about usability, right? We're trying to design technology that people are going to want to use. If you have someone that's working at the line there next to a robot and they also have to wear this technology and so they have to wear this and so on, there might be safety issues, it may be heavy, it may be warm in the factory, who knows? We need to think about that, right? We have option A and option B. Option A is offload some of the tech to the person or try and do it all on the robot. And the only thing the person has to do is do what you would do in the normal manner, and the robot will react to you.
I mean, I'm actually kind of thinking, kind of like maybe have sensors on it, kind of like the lead motion device, where it would like shoot out infrared in some capacity and see like where that goes.
Okay, right, so we could put infrared or cameras or what's known as LiDAR. So basically getting a point cloud, which gives you a three-dimensional picture of everything around you, right? Good solution, extremely expensive. A LiDAR sensor also gives you back a huge amount of data, right? Think about the amount of data that just the Leap Motion device is collecting. LiDAR is not just giving you the X and Y and Z coordinates of all the points in the hand. It's giving you a point cloud with hundreds of thousands or millions of points every microsecond, right? You need to take that and infer where's the person, where's the person's hand, where's the person's face pointing, and so on. Might be a good solution, but raises a whole other bundle of technical challenges. Okay, so all of these are more or less hiding the technical details, but I'm trying to show you how thinking about P and A and C influences the way we think about T. Okay. Let's think about this slow feedback loop now at the bottom of the slide here, assuming that the price of co-robots came down, so now we have co-robots that are working in factories. Maybe we have some co-robots in schools or in the home where they're working physically right next to someone. How does that change the way in which people might interact with each other?
If you have a screen and a camera, you can do like movable Skype.
Movable Skype. Tell us more about movable Skype.
Like you can walk around the house while video chatting with someone or show them a new building.
Okay, so the co-robot is following you and it's capturing and you're broadcasting. Yeah, that could work. Movable Skype, I like that one. What else? So I have a co-robot and you have a co-robot at home. You can't make it to my office hours or the TA's office hours, but you know that I have a co-robot and you have a co-robot. What can we do together that might have been harder than before? So maybe I demonstrate some physical interaction to my co-robot, which is then replicated in your co-robot, and you're seeing me demonstrate something like how to use the Leap Motion device right there, right? Think about learning a new instrument or a new physical skill. Are there ways that you could change how you actually teach someone physical skills? Again, assuming that both participants have a co-robot. Maybe that's not going to happen in the immediate future, but you can start to think about some of these things that might be easier to do once everybody has this technology.
Just gonna say, have you ever seen the movie Real Steel? They have robots that box.
Oh yes, the robot boxing. Yeah, exactly. Right. Okay. Good example. Okay. All right, so let's now unpack P and A and C in a little bit more detail. Hopefully I've impressed upon you about why they're important, and we sort of just did some freestyle brainstorming about P, A, and C. Can we systematize this a little bit? We're working towards taking all of these observations and formalizing it into a design process. Let's start with people. So we say, okay, we want our software to be used by a large number of people. The moment we mention quantity, we definitely are going to have people that differ and differ in different ways, right? So physical differences are obvious once you start thinking about them. We've already sort of covered that with Leap Motion. What about psychological differences? So people have different cognitive biases. Some people prefer to watch the YouTube instruction video. Some people would prefer to watch the captions. Some people want the audio. Some people want combinations of both. Some people prefer, if they're learning something and are interacting with the system, to receive the feedback along a visual channel, an auditory channel, or both. There are obvious cultural differences. One aspect of culture is language, and there are some important language assumptions that are built into a lot of software today. If you see these 4 buttons in an app without, again, having those labels, you know exactly what they mean, right? If Hebrew is your native tongue, how do you interpret these symbols? The other way, right? So if you read from left to right, it makes sense that this particular arrow and this one mean back in time, and the other two mean forward in time. Why? Why does that have anything to do with reading left to right?
That would just be common sense, because I mean that's what they're used to. I mean,
It's what we're used to, but why? Why is it that left means into the past and right means into the future?
Because the left stuff is the things you read first, so when you finish reading, it'll be the left, like the most furthest away.
Exactly right. Whatever word you're looking at or image you're looking at, the stuff that's to the left presumably is stuff you've already seen or heard or read, and stuff that's to the right is stuff that you're about to read or hear or see, right? These arrows may not be forwarding and backwarding text. It could be anything, right? It's again a visual analogy that builds on the cultural, the Anglo-cultural predominance of the internet, right? The vast majority of internet users read left to right, although that's almost changing. So if you were developing this for a culture that reads right to left, you need to make a decision, right? Are your users going to assume that left means forward in time and right means back in time, or?
And could you just change like the orient? Like, so let's say you have a video player. The video player moves like that until the video's done, like a little indicator. What if you just had to go the other direction?
Absolutely,
Use
right?
the same symbols.
Now, would you do that? Again, let's think about the P and the A and the C. Most, yep.
well, I mean, if I had a website or something where the focus was internationally, you could detect where the person was using it and have the code change.
You could do that, right? So we could decide, we could go with the design option that we're going to make it automatically adapt to usage, right? Try and infer something about who's using it.
Then it depends on if they've been using the internet for a while, they'd be used to the old version and they'll get confused when they change it up.
Of course, right? So this example is a bit of a trick example, right? Most people know that the internet is now Anglo-centric, right? And things that move to the right are going forward in time, which takes into account culture, right? Most people coming to the internet or whatever, they've been already exposed to YouTube and all the other stuff, which is communicating to them explicitly or implicitly, future is to the right and past is to the left. And we assume that most people who see this in a new app have a particular expectation in mind, right? They assume, even if they are not a native English speaker, that right is to the future and left is to the past. We're thinking now about the mental models that people make or have that they bring to bear on a novel interactive technology, right? Is their expectation deriving from the fact that they read from right to left, or is it deriving from the fact that they know the internet is Anglo-centric? Right? Maybe we want to do a little bit of alpha testing, not put labels on this, and see which button they click if they want to fast forward or rewind, right? And figure it out that way. Okay. Usage differences, also this sort of comes into it, right? Are we dealing with amateurs? Are we dealing with pros? Is there something about our software that advertises that there might be keyboard shortcuts or ways that you can fast forward through and do things faster or not? And how do you advertise that to different users? Maybe you do some adaptation and try and infer, is this someone using Leap Motion for the first time? How would you know? And if they are using it for the first time, what do you show them? If you immediately infer that they've used your particular software many times already, what do you present to them? Okay, I think we'll stop there. You have a quiz due tonight, and deliverable 2 is due next Monday. Have a good rest of your day.